All right, we got a geometric sequence here. We're going to be having a common ratio between 3 to get to negative 15 to then get to 75. So the first thing you're going to need to do when asked to find the nth term of this sequence, so instead of saying, what's my next one, what's my next one, what's my next one, and going 9 times out, we have a formula that we like to use, and it looks like this. AN equals first term times ratio n minus 1. Now, R is going to stand for the common ratio that we determine is between these three numbers. How do we find that common ratio? I showed you a video on that already. If you watch one of my former videos that I just posted, we're just going to take our second term. We're going to divide it by our first term. That would be negative 15 divided by 3. That gives you the common ratio of negative 5. So we know in this pattern, in this sequence, we are constantly multiplying by negative 5 times negative 5 times negative 5 times negative 5. So instead of doing that 9 times, we can just plug our information into this formula right here. Let me box it off so we can separate it from the question. So this is our formula right here. Let's use it the way it's intended. Negative 5 is our common ratio. We just found that by taking our second term divided by our first term. So that value has to go where R is. N is going to be the term in which we're trying to get to. In this case, it's the 9th term. So we're going to have a 9 right there where the N is represented. And A1, that's good sauce. That's a good steak sauce right there, baby. But A1, that's our first term in the sequence, 3. So all we need to do right now, I'm going to put negative 5 off to the side right here as our common ratio. Common ratio. Negative 5. Okay. And we're going to write this out. So AN is what we're trying to find. That's our nth term in this sequence. A1, that's our first term. So in this case, it's a 3 times our common ratio of negative 5 to the power of n minus 1. N is 9 minus 1 because 9 is the term in which we're trying to get to. So once you write it out, it's just a matter of solving it. So 9 minus 1 is going to be the first thing we need to do because we always start with parentheses. So now we have AN equals 3 times negative 5 to the power of 9 minus 1 gives me 8. Now negative 5 to the power of 8. I'll just grab a calculator and do that part. Negative 5 to the power of 8, leaving me with 390,000. Woo, doggy. So now we have AN equals 3 times 390,625. And our last and final step is taking this value here, multiplying it by that value there. 3 times 390,625 times 3. And we're all the way up into the millions. We're going to have AN equals 1,171,875. Now you can find any term you're asked of. All right, so I could ask you to find the 12th term. I could ask you to find the 3rd term, the 5th term. All you have to do is change this value of 9 to whatever you're being asked of in the formula. So our nth term, in this case being the 9th term, when we're multiplying by negative 5, multiplying by negative 5, multiplying by negative 5, multiplying by negative 5, and this scenario would come out as 1,171,875. Study hard and good luck on your upcoming test.